That's gonna be exciting.
Totally. So it's going to be just like this once you turn those into Z-scores. It's going to be exactly the same. Yeah, because then you know where to put those. Yes.
No, I was just thinking, I don't want to.
All right.
Did the lights go down?
Huh?
Did the lights go down?
Yes. Sorry. All right, guys, I'm going to catch up to you. And again, the reason I do these are officially known as guys. They're not known as guys, but just these are officially known as like low stakes things. I'm not going to grade this. This is a brand new idea. We haven't worked with it much, so you're supposed to kind of have trouble with this. Mistakes is how we learn. So if you never make mistakes, you're not going to learn shit. So let's make some mistakes. So a few things I want you guys to get really, really used to with this. I made this picture for you. I'm not going to always do that. So you got to be able to make yourself a little normal curve. Hopefully it shouldn't be that crazy hard. What goes in the middle of this one, of course? 0, because we're talking about z-scores. Where's 1.17? Up here somewhere. Is that cool? And where am I going to shade? Yeah. So this question is beautiful because the chart always tells me areas below a z-score, and the question wants an area below a z-score. So I should look it up and be done with it. That kicks so much ass. So if I look up 1.17, what do you guys get? 0.8796. What does that mean? I love it. You guys are like, I don't know, man. It's the number we got. This shit. It's your chart. Can anybody tell me what that means? There's a few different ways to answer that question.
It's the amount of data points, standard deviation, mean, whatever. I'm sorry, I had it.
Man, I was so excited. I'm sorry. I don't mean you.
No,
I
it's
appreciate you
okay.
tried. Yes.
It's a percent.
True. So there's yes.
Would it be the area?
Yes, sure. So area, percentage, probability. In these kind of problems, they all mean the same thing. And that's why I started with dartboards and stuff to really focus on area. And then everyone's like, well, if the whole area is 1, then little chunks of area are related to probabilities. So I could say that almost 88% of z-scores in a normal curve are below 1.17. That's one way to say that. Or you could say a specific situation like if your height has a z-score of 1.17, then almost 88% of people are shorter than you. Do you guys see what I'm saying? Yes, maybe. Was that a part of this question? No. Could Jeff ask you a question like that? Oh, hell yeah. All right, so here, again, what goes in the middle? Crazy. Where's negative 0.56? This right somewhere. And I want the area that is up here. I like it. So already I know it's going to be bigger than 50%. I know it's going to be bigger than 50%. So for the people that don't draw a picture, they are going to do this. I got to look up what? Negative 0.56. Negative 0.56. 6. Where's 6? There you are. 2877? Okay. So the people that don't draw the picture, they look that up and circle it, and they keep going. They're going to lose at least half the points. Because they didn't answer the damn question, right? How do I answer the actual question? 1 minus that. You guys remember the little shortcut I told you? Make everything 9. How do I make that 9? 7. How do I make that 9? 1. How do I make that 9? 2. Make the last one 10. Done. Or you can use your little calculator, whatever. We should be able to be better than calculators. We invented those things. We're the freaking humans. We should be able to be better than them, yes.
How many points would it give if we don't do
I have no idea. Well, for that problem, you would lose at least half the points for that problem. Depending on how long the thing is, if it's a quiz or a test, I don't know the specific number of points. Do you understand? I don't know. You will lose at least half the points for that problem. That doesn't sound fair. I don't care. So what about this guy? One big thing I want you to, what does this z-score tell you?
Not a standard deviations away.
To that
Data point.
data point. Kick ass. And you know I'm going to ask you a question like that on the second test, on the third test, on the final. And I'm hoping I get more than 50% finally someday. More than 50% of people will get it right. So a z-score tells you the number of standard deviations from the mean to a data point. So if I ask you, what does 2.17 z-score mean about a data point? It means that data point is 2.17 standard deviations away from the mean, or even better, above the mean, because it's positive. Are you guys? Those are the two kind of questions I'm definitely going to ask you on all the tests left. That is a gimme question now that some of you guys just don't want to take. I don't know why. But, you know, it's your right to lose points. So, what was my point? So never subtract z-score shit. If a z-score tells you where you are and you subtract z-scores, you are somewhere else. You only subtract areas. That's what makes physical sense in these problems. Don't subtract z-scores because all of a sudden you're somewhere else. Okay, maybe. So in this problem, let me see, there's 0, there's 1.42, there's negative 2.67, and I want the area between. Is that cool? If I look up 1.42, is that too much area or not enough area? Too much. Exactly how much too much? This much too much. So of course I'm going to subtract those areas. Because if I subtract this much off, I'm going to be left with just this much here. It makes complete physical sense. It's my hope that you realize. Okay. So what do you get when you look up 1.42? 0.922. And then what do you look up when you what do you get when you look up negative 267? 0038. So of course, if I take this minus this, it leaves me with this. Let that make complete sense. And if you draw the picture correctly, it should help you remember that. So what do you get when you subtract those two things? 9184? Yeah.
Professor?
Yes.
So when you draw the line, so the probability of, the z-score is greater than negative 3.67, so the line will go inside
No.
this way?
No. Nope.
Uh,
So, I always get people that do that. I don't want to get this area that's not going to help me worth anything. Because again, when I look up 1.42, why doesn't that number answer the question? Because it goes too far. Where do I want it to stop? Right here. Right? I want the area between those, not the area below that all the way down. I want to stop there. So how much do I want to cut off of this dude? Exactly this much. I don't have to make the arrow go any other way. Is there a way you could do it that way? Yeah. Does it double the work you got to do? Yeah. So why would you want to? Yeah. So please let that make physical sense. When I ask you between two z-scores, you're going to end up subtracting two areas to get what's left in the middle. I like it. I wonder how many of you guys got my reference. All right. Continuing on. I really want this to make sense. Could you, if I gave you, do you guys remember this kind of problem?
I got 2.8 feet of wood. How many inches is that?
Have you ever in your life converted between like inches and feet? How many inches in a foot? 12. 11. Do you, real quick, little side note. Every other country on the face of the earth now uses metric. What's better about metric? I don't know. It's based on 10 like our number system is. Okay, sorry. So if you're here from another country, I apologize to you on behalf of the math community and the science community. We do what we can, but my God, it ain't never gonna happen. There's no merge. All right, sorry. So, this inches and feet question only would happen here. When I use the z-score chart, is a conversion between z-scores and areas. So can you convert from feet to inches? Yes. Can you convert backwards from inches to feet? Yes. So I can convert a z-score into an area. I can also convert an area into a z-score. Same idea. So if I look out here and go in, I'm making a z-score become an area. If I look in here and go out, I'm making an area become a z-score. Because math can always go both ways. Be jealous. So, I already did a little bit of this up here. 0 cuts it in half, so the answer has to be about right here somewhere. A little bit above that, so that ends up having 58% below. So I know it's a percentage, I'm going to put it up there. I don't know the z-score yet, I'm trying to figure it out. So I am not going to do this. 0.58, no. Because 0.58 is not a z-score. Does it look like a z-score? Yes, the evil little thing. But we got to remind ourselves, it's an area. What's the closest I can get to 0.58? This one's 32 away, this one's 7 away, so this one wins. So it's 0.20. So this z-score is 0.20. So if I go 0.2 steps above the mean, I now have 58% of the data below me. So what's a little different about this one? This one has an area that is above. Oh shit, that chart doesn't understand that word shit. You guys understand what I mean when I say that? The chart only understands areas that are where? Below. So if I put, where's that gotta be? This part, I want this to make sense. 0 has what percentage above it? 50%. So where's the z-score that only has a little tiny 5% above it? It's gotta be way up here somewhere. Little tiny 5%. And I want to make that into a z-score somehow, but the z-score chart does not understand areas above something. It only understands areas below. Well, what's the area below this? Yeah, 95%. Yes.
So why the 5% we're not counting from the 0? We have to count from outside to the 0. You know what I mean?
No. Say it again.
Like
sir.
5%. Why it's not close to the 0?
Oh.
It's like 5.
All right. So
5%.
0.05 z-score would be really close to 0, right? It's like a tenth of a half of a step would be it. But this is not a z-score. This is an area. This is a percentage. It only has 5% above it. That's what that says. So it's got to be a very small area, 5%. And the rest of this area is 95%. So one of the most evil things about z-scores and probabilities is they look like each other. If I just say 0.93, is that 92% or is that z-score 0.93? I don't frickin' know unless I see it in a problem. You guys see what I'm saying? I'm just trying to tell you what to be careful about. We're the humans. We're supposed to know, is that a z-score I'm looking at or is that a percentage I'm looking at? And then you know where to put it on the picture. And again, we're just starting to use this stuff. So you gotta get used to it. Okay. So what's the closest? What happens that's interesting about 0.95? Do you see how it's on either side of 164 and 165? So if you follow the little magical trail, wee-haw, they split the difference, 1.645, and it happens in a few places. So it's 1.645 z-score. So if you go up 1.645 steps, you have only 5% left above you. So if you got a 1.645 z-score on a test, what percentage of people scored higher than you? 5%. So that's pretty damn good. I don't know why I'm talking like this. That's some damn good shit right there. All right. Now number 2, well, what's going to be in the middle of all these pictures for number 2? 33.64. I just made this shit up, but does it sound right? I mean, now you guys get here relatively early, so there should be a decent number of parking spaces, right? It's the people that get here like 10:30. Feel, you know, oh my God, what a horrible life that is. Because 10:30, you guys with me? 10:30. Oh man. I just remember my grad school, they sold 2.5 parking permits for every 1 spot. So every college basically does that, so. Yay, all right. Where's 27.2? It's over here somewhere. And I want the probability less than that. That kicks so much ass. So if I had a z-score, I could look it up and be done. By the way, why am I allowed to use a z-score chart for this problem?
Because we have the standard deviation.
That doesn't matter. It's normally distributed. Sorry, I didn't mean to be so mean. Don't matter, what are you talking about? You can always make a z-score if you know a mean and a standard deviation, but when can you convert it into a probability if it's normal? So what's the one thing I got to do here? Got to take this and make it into a z-score. X minus the mean becomes 6 divided by standard deviation. What do you guys get for that?
-0.7.
2.73?
Yes. 0.9.
So if I look that up, I'm going to be done. Because the problem wants the area below. So negative 0.73. So I get 2327. Get X. So you can see me. So please, dear God, do better than me. My God. There. When you write the answer down, circle that bad boy, and make sure I know where it is. Okay. All right. Same thing on this one. Right, what goes in the middle? 53 is up here somewhere, and I want the area above it. So then what do I have to do with this? Make it into a z-score. X minus the mean divided by the standard deviation. When you put this in your calculator, just make sure you tell your poor little calculator what the top is, because it don't have eyeballs. Thank God. Creepy as hell. Or is it just me? It's just, you guys are ready for it, I guess. What do you guys get for the z-score of that? 2 point something. 2.2?
Yeah.
0? Okay, that sounds familiar. If I look that up, is that going to be the answer? No. But I got to look it up anyway, right, to get to the answer. So 2.20, 9861. So what's the right answer then? I've got to do 1 minus that. I get 0.0139. And that again, if you wanted to, you could have looked up negative 2.2. But if that doesn't quite make sense to you, forget about it. We just did the problem. We don't need the shortcut. All right. So this one real quick. Maybe you guys can help me make this one quick. So I got 2. This is going to be just like this problem was. Once I make z-scores out of these things. I'll make a z-score. So what do you guys get for the z-score for 15.5?
-2.06.
2.06? Does that sound right? Okay. What about for 29.5? Sounds about right. Is that what you guys got? Yes? Okay. So then if you look up the areas, negative 0.47, I get, what do you get, Jeff? 3192? Is that what you guys got? 3192?
Yeah.
Yeah. And then when I look up negative 2.06, I get 0.0197. Yes? And so what do you have to do to get those four little dudes? Subtract. If you subtract them, you get
Why do you subtract? Oh.
you subtract because this one goes too far. If I take this much off, I'm gonna end up with the amount that's in there.
Just the way you did it, you're finding the z-score to the other side. You drew another arrow.
I'm sorry. There are a lot of arrows up there. It's like a John Madden thing.
Then this guy was.
I can't do John Madden. Yes. I think that's what that was. When you look up negative 2.06 in the charts, negative 2.06, you get 0.0197. So now, when you subtract those, what do you get? 2.995? So about 30%, almost 30% of students take between 15 and a half and 29 and a half minutes to find a parking spot each week. That's how to interpret what that means. And then finally, all right, this formula here. I don't know if you can see it, hold on. That formula then, let me write it again. What is it good for? Absolutely nothing. No. If I have an x, I can convert it into a z, right? What if I have a z-score and I want to convert it into an x-score? Here is why in algebra we teach you guys how to work with just the letters. I don't know if we've done this already. How do I solve this for x? Multiply by the standard deviation. And then add the mean. So x equals mu plus z sigma. If I add the mean over, is that cool? So here's something really, really cool. Those of you listening, this is going to be a nice note that I have to let you have because it's a formula. What does this z-score mean? The number of standard deviations from the mean to the data point. If I start at the mean and I go this many standard deviations, I get to the data point. Almost every formula is just a sentence that hasn't been translated yet. So I translated that one for you. So what's that got to do with this freaking problem? Freaking problem. So I know the 14th percentile. Where's that going to be? It's going to be down here somewhere. So that's 14%. Right? Now, from that information, I could find the z-score, but what does the problem want? The time. I got to convert it back to an x. So what's the z-score that has 0.14 below it? Should get one really, really close to it. See that one?
-1.
Yeah, so negative 1.08. 1.08 negative. Negative 1.08. So I know the z-score, I want to make an x-score. Well, now I have a formula that is built to do that. The x is the mean, and I want to go down 1.08 of these. That should look very familiar. We had to do that in section 270, I had to do that in the first test. And then whatever the hell that is. What do you guys? Anybody do that yet? Is that about 44? I mean 24? Go the right way, Jeff. 24.13 minutes. So if it took somebody that many minutes per week, they would be in the 14th percentile. Is a lower percentile good in this problem? Yes, because that means it's taking you less and less time to find a spot, which I would think most people would think that's good.
Man, that took too quick, man. I wanted to take like half an hour.
I don't hear that too often. Oh man, that's a lot. So you have got, there's only 2 sections in 6. But I'm pretty sure I told you guys that chapter 6 is the most important chapter. Because almost everything we do after this is going to be related to the ideas in chapter 6. I like it. I'm good. We got done early. We got done with everything I wanted to do. So that's plenty. Does anybody have upset at me for not giving you your full money's worth? You are? Okay. You got it. I had somebody actually get mad at me.